Today's video is brought to you by candy, my favorite candy. Our title of our notes is 4-5, Other Ways to Prove Triangles Congruent. And you know, that's your book's title. I would call this 2 additional ways to prove triangles congruent. You already know 3 ways, side, 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 and angle, side, angle. We're going to learn 2 new ways to prove triangles congruent. Now, to set up your notes today, split your notes in half. You're going to be playing an online game today and recording questions down here, and you're going to be writing 2 theorems on the top. So the notes are relatively short today. What are the ways you know to prove triangles congruent? I already said them. Side, 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 and angle, side, angle. Now, we're going to add 2 new ways to this list. Starting with theorem 4-3. And 4-3 is angle, angle, side. Now, here's what I wanted to show you. If you have 2 triangles where you just have 2 angles, you might think, if I have 2 angles that are congruent, can I say those triangles are congruent? Well, if you might remember this from 7th grade when we talked about similar triangles, this triangle and this triangle both have the same base angles. This one's 40 degrees, this right one is 70 degrees. But it's really clear that these outside lines are much bigger than over here. The way that they change that is by adding angle, angle, side. So let me move this out here. If you add in a side compared to those 2 angles, then you can say that they're congruent. This side right here kind of holds the proportion together. So that is the angle, angle, side. That's the diagram I'd want you to say, or to write. And this is the actual theorem. So this is theorem 4-3. And theorem 4-3 goes something like this. If 2 angles and a non-included, this is kind of a new word, non-included side. So if 2 angles and a non-included side of one triangle are congruent to the corresponding parts of another triangle, then those triangles are congruent. Now I know we lost some of that, so let me move that over. So let's read it. If 2 angles and a non-included angle, so it is angle, angle, side, angle, angle, side, are congruent to the corresponding parts of another triangle, then those triangles are congruent. So what do you know? There is an AAS, but you might want to note there is no AAA. So now we have our list, side, 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 angle, 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 side. And now I know you've been waiting to ask me this question. What about side, side, angle? Yeah, that's the way I'm going to write it. What about side, side, angle? Does that one exist? The answer is yes and no. Let's just say that I have this angle, this side, and another side. I could say that that side length is, let's say, 1 inch. Okay? Now, if I measure that 1 inch, there is a possibility that 1 inch will land here, but there's another possibility. I could also draw that exact same picture, but instead of having the side land over there, the 1 inch could be more concave, 1 inch. So the truth is that there is a side-side angle, but it all really depends on this upper angle right up here. And it really also depends on the degree measure of the angle. So I'm going to move all this out, and let me show you, do the big reveal. By the way, this is a Snickers almond, if you wanted to know. That is my all-time favorite candy. This right here is a special kind of triangle, and it is a side-side angle, but instead of calling this side-side angle, They kind of renamed it, because who likes that name, to call it HL. And the H stands for hypotenuse. Hypotenuse. And what do you think the L stands for? Yeah, leg. This vocabulary comes from the Pythagorean theorem. Now, if you don't remember this, you definitely want to label that the hypotenuse is the side across from the right angle, and that the leg is one of the other sides. So it could be this one. You should note it could also be this one. So this is a form of side-side angle, but it's specifically hypotenuse leg. It only works if, what? Look at that. Whoa, whoa, whoa. What does that have to be? Only works on right angles, right triangles. So here's how this theorem goes. This is theorem 4-4. Here we go. Theorem 4-4 goes something like this. In a right triangle, that's the important condition, if the hypotenuse and leg are congruent to the hypotenuse and leg of another right triangle, then those triangles are best friends. No, then those triangles are congruent. All right, I'll move that over a little bit. They all fit. There we go. So just to read it one more time, in a right triangle, if the hypotenuse and leg are congruent to the hypotenuse and leg of another right triangle, then those triangles are congruent. Okay, Okay, the first thing I need you to do, we're now in the lower half of your notes. I want you to copy this at the top so you know what the practice is. Here's what it says. Write 5 questions from your game below. Include the multiple choice and diagram for each and record your answer and the correct answer. I want to know what you put, and then I want to know if you wrote the right answer. And you know what? I'm not going to mark you off if it's wrong. I just want to know if you're getting them wrong. So in your paper, this is how it's going to look. When you go back to Edmodo, there's a game link, and it's going to take you to a game right here. And you're going to use your left, right, and down arrows to move these pieces into either the reject pile or the triangle pile. When you make a mistake, one of these questions pops up. Now, if you don't feel like playing the game, just get it wrong 5 times and copy down the 5 questions. They're different questions. They're review questions about proving triangles congruent and isosceles triangles. So make sure you copy the diagram, all of these, and I'd like to see 5 questions total.